Math 1314, Section IC1, Spring 2022, Tyler Junior College. Section 3.5, Solving Quadratic Equations, the Square Root Property. Video 1, the Square Root Property. In the previous videos, we learned how to solve quadratic equations by factoring. Just as a reminder, it was 4 quick steps. You got the equation equal to 0. You got it factored, so written as a multiplication problem. Then you set each factor equal to 0 and solved each of those smaller equations individually. But there's a flaw with that approach. The flaw is in the factoring step, and it's not an issue of whether or not you're capable of factoring a trinomial. It's an issue of whether or not the trinomial will actually factor, because there are some trinomials that will not factor. For example, if we had something like x squared plus 4x plus 3, we could factor that in x plus 1 and x plus 3. So if we were solving by factoring, and that's the trinomial we had equal to 0, we're good to go because it factors pretty cleanly. But if I simply reverse the 3 and the 4, if I simply reverse the 3 and the 4, this is prime, which is a fancy way of saying it will not factor. You can try to factor it and you'll fail. And I forgot to mention on the first factoring example, if you wanted to check it, you could just multiply this out using FOIL, and you would find out that you would get x squared plus 4x plus 3. But the bottom one will not factor. And therefore, if you were trying to solve by factoring, you'd be stuck. So the question is there a way to solve a quadratic equation when either factoring is not an option or factoring is an option, but you choose not to use it because you have multiple options? The answer is yes. There's actually multiple ways, and we're going to look at the second way, square root property. By the way, the content of this video and the next video is the last content that will be tested on test 1. All right, so let's take a look at an example to motivate the square root property. Solve x squared equals 9. Now, you might be thinking, I know the answer to this. It's 3. 3 squared is 9. And you might even remember that there's really 2 answers. Do you know the other one? If you don't, that's okay. We're going to find it. But if we were solving this on the heels of what we saw in the previous series of videos, then solving by factoring might be on the forefront of your mind. So let's look at this about how to solve by factoring. Solve by factoring first, get the equation equal to 0. Remember, the premise behind solving by factoring is you want to get a multiplication problem equal to 0. So first you have to get an equation equal to 0. Well, that's easy. All we have to do is subtract 9 from both sides. And if we subtract 9 from both sides, we'll get x squared minus 9 is equal to 0. And then after that, our next move is simply to factor. Now, how easy it is for you to factor this depends upon where your factoring skills are. Hopefully by now, especially if you've watched the factoring review videos that I linked to in the Math 0314 Weekly Work 4 problems, this is a difference of squares. It's x squared minus 3 squared, and as a consequence, x squared minus 9 will factor in x minus 3 and x plus 3. And this product is still equal to 0. And now that we've got it right where we want it, which is factored on one side and 0 on the other, set each factor equal to 0, and solve. Well, that's going to be pretty easy to do. Let me see if I can. Let me do one thing real quick, folks. I'm going to try to grab everything on this screen, move it up just a little bit. I missed all the stuff down there. Not a problem. I can just move it up separately. And we'll do this. All right, set each factor equal to 0 and solve. Well, that's pretty easy because these factors are linear, meaning that their highest power is 1. X minus 3 is equal to 0 and x plus 3 is equal to 0. And if we add 3 to both sides on the left equation, we get x equals 3. And if we subtract 3 from both sides on the right equation, we get x equals negative 3, which really shouldn't surprise you because at the very beginning, when we said solve x squared equals 9, you probably at the very least thought x equals 3 because 3 squared is 9. And you might have recalled, especially since I kind of subtly reminded you, that negative 3 is also a solution because negative 3 squared is also equal to 9. But if you were thinking, I knew these answers and I didn't do all this, in other words, I got from here to here without everything in between, that's great. Is there something we can extract from this to repeat in the future, or something that we can turn into a technique and make a process, for lack of a better word, so that we can use it in the future. Well, let's see if we can figure out how to get from the beginning to the end a little more quickly. And I don't think it's going to surprise you what's going to happen. Because what if we had done this? What if we had said x squared is equal to 9 and focused on this as a problem-solving issue, the problem being I want to get the x by itself and it's not. And then the focal point is what's preventing us from this goal of having the x by itself, and how can we overcome that goal? Well, at the beginning, where it says x squared equals 9, the only thing preventing us from our goal of getting the x by itself is the square. So the question becomes, what can I do to both sides of the equation to get rid of the square? And it probably wouldn't surprise you if I said take the square root of both sides, because squaring and square rooting are somewhat opposites of each other, somewhat. You'll see why I said that later when we talk about inverse functions. But if we square root a square, it tends to cancel the power. In other words, when you square root a square and a square root can cancel. I'm going to put in parentheses usually. Don't worry about the times where they don't straight up cancel. In fact, you're going to see why it's typed usually here in just a second. If we were to just cancel the square on the x and leave us just the x, then that would get us to our goal of x by itself. And on the right side, we have the square root of 9, and everybody knows the square root of 9 is 3. I know it, you know it, your calculator knows it. Hey Siri, what's the square root of 9?
The square root of 9 is 3.
Even Siri knows it. But the problem is we had two solutions. We had 3 and negative 3. So if we just walk up to this equation and hit both sides with the square root in an effort to cancel the square, and then square root the other side to get 3, then we don't get both answers. We need both answers. So how can we fix this? It's actually pretty easy. In order to fix it, all we have to do is use a plus minus. So here comes a step, if you will. I'm going to put it in red. If you square root both sides of an equation, use plus minus. Oops. 1 second, folks. I'm going to sneak a plus minus in there because I'm doing something a little sneaky. You don't know what I'm doing, but that's okay. But there it is. If you square root both sides of an equation, use plus minus. So sure, it's okay. Use the square root to get rid of the square on the x so that you can solve the equation. But when you square root the other side, be sure to use the plus minus, because if you don't, you'll get one answer, but you'll lose one answer. And we don't want to lose one answer. You know, the homework's going to be unforgiving about that. Now, what we just did over there on the right side, where we said, let's drop a square root on both sides and use a plus minus in order to pick up both solutions that we know exist because we found them using the previous technique of solving quadratic equations by factoring. We can do this. We can square root both sides of an equation at any moment in time. If we remember one thing, we have to use a plus minus. Now be careful. I'm not saying that the square root of 9 is plus minus 3. The square root of 9 is 3, period. I asked Siri. Now, if you want to get into a technical discussion, the principal square root of 9 is 3, but let's not go down that path. But when you treat square root as a function, if you will, then it can only give you one answer, and that answer would be 3. But in the context of solving this equation, in the context of walking up to an equation, a pre-existing equation like x squared equals 9, and putting a square root on both sides, it's that scenario that invokes the plus minus. And this is what we're going to call the square root property. The square root property of equations is actually really simple. All it says is this: if a squared equals b, then a equals plus or minus the square root of b. Now, you can memorize all that if you want to. It's the square root property of equations. But think of it as, what if I was trying to solve a squared equals b, whatever b is, I was trying to solve it for a. Well, I could just break out the square root on both sides, and that would cancel the square. Pardon me. Had to sneeze, didn't think you wanted to hear it. But when you square root both sides of an equation, the thing you have to remember is to use plus minus. Now, what's the square root of b? I don't know, because b is just some generic number that we don't know. So all we can do is leave it under there without further information. But the key thing in here is to use the plus minus. In fact, if you wanted to rewrite the square root property in words, it would be exactly what I said earlier. And I'm going to say it again. I'm going to put it in all caps. If you square root both sides of an equation, use a plus minus. I think I still have that there. Yes, use a plus minus. And I'm going to put in parentheses plus minus, plus with a slash, plus minus. Because if you don't, then you lose two of your solutions. Excuse me, you lose one of your solutions to the equation. It's a real easy something to do. The hardest part is just remembering to do it. So let's take a look at a few real quick examples and we'll wrap up this video. Solve the following equations. We have x squared equals 256 and x squared equals negative 49. Now, both of them are one move away from being done. In other words, if you think of this as a goal-oriented task, our goal is to say x equals, then all we have to do is whatever is necessary to get rid of the square on the x, and that is to square root both sides. So let's put a square root on both sides of the first equation to get the square root of x squared on the left, the square root of 256 on the right. On the left side, you cancel the square. I think I'm going to put that in red in a smaller font size. But that's what you do on the left side. You cancel the square. Or whatever side the square is on. Cancel the square. But on the right side, we have to use plus minus. So when let's take that font size up one notch. I think it'll fit there. Yeah. So when you're square rooting both sides of an equation, usually because you are trying to cancel a pre-existing square, then make sure that you use a plus minus on one side. It technically doesn't matter which side you use it on, but typically you're going to use it on the numerical side. So let's go ahead and put the plus minus down here. Now, as far as the square root of 256 or any other number whose square root you might not know right away, first thing you should do is put it in a calculator and hope for the best. And if it comes out clean, then use that answer. The square root of 256 is exactly 16. So we have two solutions to this equation, x equals 16 and x equals negative 16. And in the homework, it might allow you to type plus minus 16. What about the second one? X squared equals negative 49. Well, really, it's going to be the exact same thing. The only difference here is that we've got a negative on the 49, meaning that when we square root both sides, we need to proceed with caution. Square root of x squared on the left, square root of negative 49 on the right. The square cancels the square root cancels the square, leaving an x. On the right side, we're going to use plus minus. So just go ahead and write that. And what is the square root of negative 49? Now, if you said 7, you're close. If you said negative 7, you're close, but you're still wrong in both cases. The square root of 49 is 7. Well, what about the negative? Do you remember what to do with the negative? Well, when you have a negative, you can separate it in its own square root. Oh, no, I see a square root of negative 1. Remember what that becomes? Hope you remember. The square root of negative 1 is I. The square root of 49 is 7. So together, they make 7i. Now, if you can square root negative 49 and instantly say 7i, great. You should be there at that point. If not, then go back and rewatch the videos on complex numbers and taking square roots of negative numbers. But imaginary numbers and complex numbers are going to be part of this game. All right, let's take a look at 3 more quick examples. And in the next video, we're going to look at some more complicated examples. All of these are set up the same as the first two. X squared equals a number. Could have been y squared, w squared, a squared, anything squared that we want equal to some number. It's not going to change the approach. The approach on all of them is to hit both sides with the square root for the purpose of canceling the square. Don't forget to use the plus minus. That is the most common mistake people make here. But if you have a square root that won't work out perfectly like the square root of 30, you should try to simplify it by splitting it into the product of 2 square roots, one of which you can answer. So how would you split the square root of 30? Well, if you think about it, there's no way that's going to work. You can either do 2 and 15 I don't know either of those square roots. You can do 3 and 10. I don't know either of those square roots. And you could do 5 and 6. I don't know either of those square roots. No way to break apart the square root of 30 will give you a square root that you can do. The square root of 30 looks like it ought to be able to do something, but the truth is it's as simplified as it gets. And if you want more detail on how to simplify square roots, I invite you to watch the video I created about simplifying square roots at a student's request. However, in here, I'm going to make a comment that this square root will not simplify, so that when it's saved as a PDF, those notes are in there. So it's okay for a square root to just sit there and say, I'm not going to budge, because some square roots do that. Now, by contrast, when we do the next one, x squared equals 28, and take the square root of both sides, the square and square root will cancel still. We will still use a plus minus on the right side because that's the square root property of equations. But under the square root, we have a 28, and that can be dealt with because we can split the square root of 28 into the square root of 4 times the square root of 7. And the square root of 4 is 2, so we know that answer. We don't know the square root of 7, so we're stuck with it. And our final solution is x equals plus minus 2 times the square root of 7. And again, that's just a lazy way to say x equals 2 times the square root of 7 and x equals negative 2 times the square root of 7. Excuse me. All right, for the last one, x squared equals negative 28. I want you to compare the last equation with the one we just did. What's the only difference? The 28 is negative. So when we square root both sides, the 28 is going to behave the same way. What's not going to behave the same way is the fact that there's a negative. Well, we've already talked about how to deal with a negative under a square root. Square root both sides of the equation to get the square root of x squared equals the square root of negative 28. I hate these announcements that just pop up when I'm recording these things. The square root of x squared equals the square root of negative 28. The square root cancels the square on the left, leaving just the x. On the right, we're going to use a plus minus, and now we got to fiddle around with the square root of negative 28. You can always break off a negative under a square root into its own square root as a negative 1 and leave the rest of the number alone. So we could break the square root of negative 28 into the square root of negative 1 times the square root of 28. But we already know what the negative 1 is going to do. It's going to become an I. That's the definition of I. It's the square root of negative 1. And we already know what the square root of 28 is going to do. It's going to simplify into 2 times the square root of 7. And so in our answer, we have x equals plus minus all that. Now, is there a correct order to put it in? Well, there's a couple of options. Option number 1, like most i's, is to stick them at the end and have plus or minus 2 times the square root of 7i. And there's absolutely nothing wrong with that. Give me 1 second to make some room here. There we go. And again, there's absolutely nothing wrong with writing plus or minus 2 square root of 7i. However, if you're not careful, you might accidentally put the I under the square root next to the 7, and putting it there is wrong and would cause you to miss the answer. So it's not uncommon, and we kind of had this discussion when we were talking about complex numbers. But when you have a term, a product, if you will, that contains both a square root and an I, it is not uncommon to actually put the I immediately in front of the square root, which in this case would be plus or minus 2i times the square root of 7, to remove any possible ambiguity as to whether or not the I belongs to under the square root, which it does not. All right, so the square root principle basically says if you square root both sides of an equation, use a plus minus on one side. And usually the motivation behind square rooting both sides of an equation is to cancel a square en route to solving for x. In the next video, we're going to take a look at some examples that still use the square root property, but these equations have some issues either before you take the square root or after you take the square root.